Okay, quiz number 28. We're going to do transfer functions for this passive filter. So in other words, I want to write what is the output voltage over the input voltage. In other words, or what I want to do, the transfer function again, if I write the output voltage V out, it's going to be some function h j omega times the input voltage. And this is all done in the phasor domain. Okay, so again, this circuit is already written out in terms of phasor notation. We have the minus j over omega c. I don't know, just note that that minus j over omega c is also equal to 1 over j omega c. So basically we want to find that, V out, if we were to find the parallel impedance here and then do a voltage divider, right? V out gets divided with this impedance, that impedance, so it'll be this impedance divided by the sum of the two impedances. So in other words, if I look at the parallel impedance, if I say, okay, 1 over j omega c in parallel with RL, this is going to be RL times 1 over j omega c divided by RL plus 1 over j omega c. And just to make life easy, I'm going to multiply the top by j omega c and the bottom, top and bottom by j omega c. And that means I'm going to get RL. And then on the bottom, I'm going to get 1 plus j omega RLC. Okay, so that's going to be, this is like my Z equivalent here, where this guy would be Z equivalent. All right, so my circuit now looks like the following. I have my input voltage. I've got a resistor R, and then I've got an equivalent impedance ZEQ, and this is going to be V out. So V out is going to be a voltage divider equation. So it's going to be Z equivalent divided by R plus Z equivalent, and that's all multiplied by V in. So this guy is my transfer function, and let's just write all that out. So that implies that V out is going to be this function, Z equivalent is going to be RL over 1 plus j omega RLC. Okay, that's Z equivalent divided by R plus Z equivalent, RL 1 plus j omega RLC times V in. And that's going to be, so if I multiply top and bottom by 1 plus j omega RLC, then I'm going to get RL on the top, and I'm going to have R plus j omega RRLC plus RL on the bottom, V in, and I don't know, I guess we could just rearrange this a little bit, and we're going to get RL and then R plus RL plus j omega RRLC. That's going to be the transfer function Vn. Well, okay, I could, to make it look like this, if we multiply the top and the bottom by 1 over R plus RL, this is going to be equal to RL over R plus RL. And then on the bottom, we'll have 1 plus j omega, and then RRL over R plus RL C times Vn. And then notice that this guy is R in parallel with RL. And then, that's this answer. Okay, so anyway, you put it, this is that's the transfer function associated with this loaded filter.